Hello, everyone. So welcome to the third section of the machine learning of the workflow orchestration section. In the last section, we took a Python script, a Jupyter notebook, and brought it to a Python script. We had to do this refactor because in order to productionize things, we need to use scripts instead. We have to bring stuff into functions so that we can properly unit test them also in the future. But primarily for our case, in order to get observability, we need to group stuff into functions so that we can get observability attached to each function. So here, we're in the third video now called first prefect flow and basics. So we're going to take that script that we created in the previous section. I want to iterate that maybe you didn't want to follow along when I brought that script over here. I will just push this into the GitHub repo as model training, and then I'll make a new script instead so that we leave this untouched, and the new script will be called Prefect Flow. And again, like I will also bring this into the GitHub repo just so you're not forced to really follow like every change I did in order to bring it. So here, this was supposed to be in video 2, but video 2 got pretty long. So I'm just going to talk about it pretty quickly, this use cases with MLflow. So here is a diagram from Evidently AI, who is also going to present in this Zoomcamp. And you can see that it's very natural for modeled accuracy to decay over time, right? And this is what is called drift, which they'll probably talk about more. And in order to avoid model drift, what you can do is you can regularly retrain your model, and then you can publish a new model to production. And because by doing that, you can keep your performance. So if you think about what we've been doing, we already have a script that trains a model. What we want to do is we want to eventually have the tools to put this on a schedule and output it to the proper location, right? And then aside from that, we want to be able to like whether whether it's in before we actually output it to production, we want to make that comparison. And MLflow is the one that gives candidate like that feature where you can compare the metrics against a production model, and if it's better, then you promote the candidate model from staging to production. It'll be too much to cover like that entire process, but by the end of this section, you should already have a good idea of how to do it by combining what you learned in section 2 and in the orchestration section. So here we're gonna install Prefect on local. Again, you can use the requirements.txt file. If you didn't, the command is pip install prefect 2.0b5. This should not do anything. I already have it. And then we are concerned about running everything as a flow. So I realized that my refactor was kind of incomplete primarily because I have these things up top, this thing, and I want that to run as part of my main. So I want it to run here, over here. And then I actually want to turn this into a function, right? And then this function, I want to, remember we have our train path and val path. So those ones specifically, I want to keep. I think these are the main ones that I have. And I want to make those parameters into main. And by doing this, what I want to do is I just want to call this script using main. For the purpose of demo, in order to reduce the round, I'm just going to reduce the rounds. There's another one here, reduce this round. Or maybe and then in the hyper OPT, I'm going to delete this code. Like we kind of really don't need it. So we can reduce the code here. And then I'm looking for specifically for the hyper, I want to close this 1 second. I'm looking for the hyper OPT section. We want max evals to be 1 to speed this up. This looks like I needed X train to be passed in and X val. I don't know. Oh, no. Oh, I don't think I need this section. Yeah, that worked because of global variables, but it won't work now with the main. So the main is a good test also to see that we don't have any global variables lying around. Over here, I have train path and val path, and I want to pass them here instead. Because I do that, I can now take it out here from here, the default values. I just don't want these to be hard coded. And like now people are required to pass them in. Okay, that should be good. I won't be surprised if we have some error, but we'll just run it pretty quickly. Oh, no, wrong script. Wrong script. I'm in the prefect flow.py now. So yeah, we're just gonna check everything is working, and if everything's working, then we can proceed to bring it to prefect. Perfect, everything seems to have worked. What I'm gonna do is I'm gonna bring this to prefect now. So we're gonna say from prefect import flow. And this is literally it you need. So I'm gonna comment this models search, just so we have we're only concerned about one model, speed things are testing up. And I'm gonna say wrap this as a flow. And by doing that, you're gonna notice that we actually get more logs. So here we created a flow run called Jovial Spaniel. I think that's a dog. So it'll be adjective animal name. And then everything is running as is. And when this finishes running, you're gonna see some additional logs as well. Here, the state completed. So just by wrapping this as a flow, we can bring it to prefect now. But of course, one of the main differences between prefect 1.0 and 2.0 is that in 1.0, everything inside here had to be wrapped as a task. In prefect 2.0, we give more flexibility, so you can mix and match between tasks and non-tasks, right? So as an example, over here, we have this add features. I will decorate add features as a task, and we're going to have to import that. And now what happens by adding this as a task? We can see what happens here. It will probably error out because there's just some extra thing we have to do to actually use tasks. So here we get this error, this type error, cannot unpack. So if you if you are mixing and matching Python code, like native Python code with prefect tasks, the task is by calling the task, we make a future, and by calling the future, we have to call dot result. And just by doing this, this should work. I might even lower this. We're not really too concerned. And then now, if we look at my logs, what do we see? Hey, a flow run started. Oh, flow run failed. No, not that. That's not the right one. A flow run was created. A task run was created, and a task run completed. So that is this task run. So in order to show you what happens if it fails, I can easily just throw in like a value error like this, raise value error. And you can see what happens when it fails. So hey, the task failed, there was an error, it encountered an exception, right? And you're gonna see that this is a new flow run over here. I mean, the traceback is pretty long, but you're gonna see that that's the imperial capybara. So here, what I'm gonna do is I'm gonna actually show you what's going on under the hood. And by pip installing Prefect, it actually comes with the components to spin up your own Orion like server instance. So I can do Prefect Orion start. And Prefect Orion start says, hey, there's a dashboard, go navigate here. So we will navigate there. And what we'll see is one sec. I think my API is messed up. Prefect config view. Prefect unset. You will not have to do this. This is I was playing around with something else. Prefect config unset. Okay, now you should be able to do Prefect Orion start. And by doing Prefect Orion start, you navigate to the dashboard. And we notice that there are a couple of runs here, which is kind of weird, right? Because we haven't actually spun up a server to run things against, but that's what Prefect does under the hood. Each time we do a flow run, specific, and this is these are our runs that we were specifically doing. Maybe I'll try filtering with last hour, next hour, last 1 hour. So if we do this instead, these are clearly the runs that we've been working on right now. And even though we don't have a server spin up, under the hood, by wrapping it as a flow and task, we are adding observability into it, and then Prefect updates its state to the API, and the API is now shown here in the dashboard. So this is all running locally, all for free, all part of Prefect. And now I can go to flow runs. And remember, the last flow with the value error was the Imperial capybara. So I can go into here and I can see my logs. And now this is the one where I raised the value error. So now I have the logs associated with the flow run, and I can see why it failed. Also, you'll see this radar plot. It's not too interesting. It just shows it's not interesting right now because we only have one task, but it becomes more interesting when you add more tasks. And this is basically a graph of the execution that it took. So here we only have one, and then you see a timeline of the flow. So what we can do to make this more interesting maybe is we can add more I'm gonna stop this now, and I'm gonna actually just spin it up in terminal instead. So here I'm gonna activate MLOps Prefect Orion start. So now we can have this always running, and I don't need to keep opening it. The second thing I'm gonna do is I'm gonna wrap more tasks just to show you. And this one as well, I'll make a task. And I will uncomment this. And now we can see what that looks like. I want to just run this script. Oh, my my value error is still there. Let me remove the value error. Value. Okay. Is there an error? Oh, notice there's an MLflow error, and it says params were already logged for flow run ID. Actually, I don't think that's the real error. This is expected, and I will show you why. So here there is this integrity error, unique constraint failed, and actually, that happens. I just want to point out the added observability here. Flow run, exuberant Galago, 1 out of 3 states failed. So one of our tasks failed. Why did it fail? So this is something that Prefect gives you by default that doesn't play well with MLflow. What happens is, man, I need to go to like a flow run that was working to actually show, or maybe I'll just like turn this off and then I'll show you the logs just so it's clearer. Notice there's this concurrent. The important part is over here. There is a Oh my God, sorry, it's just moving a lot. Okay, here. It's using a concurrent task runner. So what is the concurrent task runner? So in Prefect, if you have a flow and you have like, for example, you have something like task A, task B, and task C, but they are not if they are completely independent of each other, Prefect will just handle them asynchronously and just start the task as well to utilize the resource as well. So, and in order to do that, there's actually a flow runner setting here. And the flow runner, the default one is that concurrent task runner, right? So in order to bring, the problem with MLflow specifically is that you run into like these problems with these inserts happening concurrently. So you have to make this the sequential task runner, and everything will work as expected. It just our users by default, like having the concurrent task runner helps them execute their flows faster, and that it's actually useful for them because they don't need to worry about concurrency, and having just tasks that are independent will just run automatically. It's a very useful feature. But for this specific use case, we need to say this, and I will import this prefect.flow runners import sequential I mean task. It's a task runner sequential task runner. Perfect. And then now with that, this should work. And then once this works, we can now see, we can now view in the UI like a task that actually has more stuff. I mean, a flow run that has more stuff in it that we can look at the radar plot. So we have a flow run nebulous marmoset, and we're interested in looking at that. So I will go here and I will just refresh this page. We have nebulous marmoset. And now we look at our radar plot, and now we have this coexcentric, this circle, and this shows our tasks that we executed. You're gonna find that as you pass data between tasks, you're gonna find more coexcentric circles sticking out and with data dependencies showing between them. So like for yeah, for example, I think something that we can do is well, we can read the data set instead. Like for example, if we did like X, but we'd have to edit. So X train, read data set, read data frame, train path, and we xval is equal to read data frame val path. And what we can do is we can try passing it here instead, this X train and xval. In order to do that, we're going to have to edit the original function definition. So over here, because we take in a path, add features, we're going to say this is, we're going to comment this. And we're going to say df train. And we're going to say dfl. And ideally, this should give us more stuff to see in that radar plot. So what happened is we made, oh, sorry, read data frames, not a task. We need to make it a task as well to get this behavior. So no, just remember, tasks are observed. Tasks are the unit of monitoring, and tasks get decorated on functions, which is why we had to take that notebook from before and decouple them into functions so that we could provide observability. And tasks is what gives us is what marks it to Prefect and says, hey, Prefect, I really want like this to be monitored. And then the task is also the one that takes in the retries. And you can see the other stuff that it takes. We're still going to like tasks also, for example, they have results or caching, for example. Caching is a good example where if a task was already ran previously and you wanted to cache it for the same day, then that task won't run again. It will just fetch the result from the cache, right? So over here we're going back to our flow run, and this is the latest one. You notice we have 5 task runs now because we added this read data frame as a task. And now if we look at the radar plot, we're gonna see this like coexcentric circles. I believe that's the right word, where, hey, this read data frame over here pass its data over to add features. And same thing with this read data frame, it pass its data to add features. So as you move more and more, you kind of see the dependencies between tasks, and like, hey, if some upstream failed, you'll see like, hey, maybe this downstream didn't trigger, or that downstream also failed as well. Just checking the our outline here. So there's one last thing I want to show you, and that's parameters and type checking. One of the nicest things about Prefect 2.0 is how it treats parameters. So over here, these are actually the parameters into our flow, right? And what's interesting is that this is a parameter, and it's saying that this is the default value of that parameter. And then that is passed on here. But what happens if I actually called it with invalid parameters? I think this should be enough. And I can just call this. And you're going to see that, well, part of it still ran because of the, sorry, I didn't annotate it. So in order to safeguard this, you need to annotate. And now what happens is when this thing comes in, when the variable comes in, Prefect will try to coerce it using Pydantic to this appropriate type. So what you're going to find here in this next run is that it will fail, and you're going to see an error. Oh, no. I know what's happening. This is because one can be still treated as a string. So I really need something that cannot be coerced to a string. Maybe this is not a good example. Maybe I'll just do like a PD. No. The problem is anything can be coerced to a string. So in order to just demo this for you guys, I'm gonna just take this out, and I'm gonna make another flow. And this flow, just to show you what the parameter validation looks like. Let's say it takes in an integer, and it does something like a print x+1. Now you can call it with my flow. And instead, we're going to pass in 1a, and we're going to see something that can't be coerced to an integer. And now we're going to see what the error is. It's going to say, hey, invalid parameters, and is marked as failed. So this is very useful because if, for example, you pass in a wrong parameter and can't be coerced, and note that this can also be complex data types like pandas data frames and stuff, if you give the like how to construct it using Pydantic. Now what happens is that it will mark this as failed before any work runs, so you don't waste any computation, right? The problem here is just that anything can be pretty much coerced to a string. So a string is like very, very generous. So we don't really get that benefit. So I am going to stop there for this section. So I just want to iterate what we learned in this section. In this section, number 1, we learned how to get the script from the previous section, and then that was already had modular functions, and we learned that we can bring it to a flow just by wrapping the flow decorator. That's it you need in Prefect. The Prefect flow can take in both Python code and Prefect task side by side. You just need to call .result on the task sometimes so that you can work with Python. But now this lets you do stuff like conditions also, like if train .shape is 0, don't run the rest of my code, right? You can do if else inside this block. I also mentioned the default is a concurrent task runner, so you have to change it to a sequential task runner. Otherwise, MLflow will run into problems writing into the same experiment. I also showed you that by changing by changing this into a by changing a function into a task, you get observability into the task, you get the logs out of it, and it appears in the dashboard. Note that we spun up Prefect Orion on our own local. Just with the pip install, we just did Prefect Orion start, the UI comes with it, it just works. And now we can visualize it in the UI and see all the flows that we've executed previously. So that's the basics of Prefect. In the next section, what we want to do is we want to actually, instead of running this locally, we want to run this on an AWS VM now. And instead we'll be connecting and running our flows against that VM. So with that, I'll see you in the next section. Thank you.